nature of the bond that we'll discuss first of all. Now, halogen atoms are more electronegative than the carbon. See, for example, if I write what happened, carbon and X means what actually? X means what?
Halogen.
Fluorine, chlorine, bromine, iodine. X equal to chlorine or bromine or iodine, you can take here. Now, when you compare electronegativity between carbon and halogens, which is having more electronegativity, carbon or halogen?
Halogen.
Definitely, this is having what? More electronegativity. Therefore, it will get negative character. Where carbon is having low electronegativity, it will get positive character. Now, why I'm writing here delta, you know, why I'm writing, why can't I write like this? Cx minus and plus. Why I'm writing like this here? Is there any reason? This, tell me. Because it is covalent bond. If I write NaCl, NaCl is an ionic bond, right? NaCl is an ionic bond. So you can put positive directly, you can put negative directly because it is ionic bond. These are ions. One is cation, other is anion. But here it is covalent bond. So covalent bond you can't break permanently like this. So partial positive we get, partial negative. Partial delta indicates what actually? Partial positive or partial negative. So this will only for what? Covalent bonds only, isn't it? So now what I'm saying here, halogen atoms are more electronegative than the carbon. So carbon halogen bond of alkyl halide is polar. Now this bond is getting what? Polarity. This bond is getting what? Polar in nature. What is meaning of polar? Means developing of positive and negative charge. Okay, if any bond develops positive and negative, that is called what? Polar. For example, if I write what? Hydrogen and hydrogen, this is non-polar. This bond is actually what? Non-polar. Why it is non-polar? Because between these two atoms there is no electronegativity difference here, so they are called non-polar, right? Now, let me move to what next here. If you observe what happened, this one you observe here very easily. Carbon is getting what? Partial positive character, halogen is getting partial negative character, right? Next, there are some more relations we will have discussion on. Let me say something, this one, next we get this one, okay? Bond strength, okay? Now I'm saying what bond strength is inversely proportional to bond length. Is it correct or not? Why? Because if you have what more length, if you have what happen, if you have more length, we can easily break. So if we have short length, what happen? We need to force more actually to break that. Okay, more force is required, more strength is required to break short bond. For example, you're having something, C something. Just imagine, it's not correct, but just imagine like this. This is what more bond length. So you can easily cleave this one. But this is cleaving what happened? Very difficult. Why? Because carbon nucleus and carbon nucleus is what actually near to each other. So in that case, what happened? We need to use more force to break the bond because you have to overcome the nuclear force of attractions. But here what happened? Bond length is more. No, when you have more bond length, nuclear forces distance will be less, more actually. In that case, we can use what less energy to overcome the whatever the nuclear force of attractions here. So what I mean to say is that very simple. When you have more bond length, bond strength will be very less. This is not correct. CCC you can't take like that. But anyhow, to understand what happened, I have taken CC actually. CC we can't take actually like that. Okay. Next thing, bond length is directly proportional to atomic size of the halogen. For example, if I write what happened, CF, okay, and I'm writing here C chlorine, C bromine, and C iodine. Can you say is it decreasing order or increasing order of bond length between carbon and fluorine? Is it possible for you?
Increasing.
Increasing order or increasing order for this of bond length? Anybody? By seeing this expression, bond length is
increasing
proportional to atomic size of halogen. Tell me now.
Increasing.
Increasing.
This is having more atomic size. This you have to observe halogen. This halogen is having more atomic size. More atomic size. Now this halogen, if you observe what happened, less atomic size. It is having less atomic size. Okay. Less atomic size. Because of this, what happened? This is having what? Less bond length. Less Bl for bond length. Okay. Next, iodine is having more atomic size. It is having what? More bond length. More bond length. Now, based upon this, which is having more bond strength? Tell me. CF bond or Ci bond?
CF.
CF.
CF bond.
CF bond is having very less bond length, therefore it is having more bond strength. I can write here what happened? More bond strength, isn't it? More bond. Bs for what? More bond strength. This will have less bond strength. That means, isn't it? We can break easily Ci bond. I can break this bond very easily. Okay, this bond I can break very easily because it is having what? Very high bond length actually. For breaking the CF bond, what happened? We need more bond strength, more bond energy we require here. For breaking what? CF. Now, which can easily participate in the bondings, which can easily participate in the reactions? Ci or CF?
CI.
Ci is easily participate because it bond easily cleaves. No, when this easily cleaves, what happened? Therefore, what happened? It will participate readily. I want to break CF bond, okay, and I want to break Ci bond. So, in the case of Ci, I can easily cleave this one. So, this will participate readily in reaction. This will need some energy to participate in the reaction. Why? Because the bond strength is what? More actually. So, these 2 points are very important, isn't it? So, bond strength is inversely proportional to bond length. Bond length is directly proportional to atomic. Don't buy hard the things. Very simple. If you have small length, we need to put more effort to break that. So, this, if you remember what happened, remaining you will get it. So, actually, this is the thing actually. If you observe what happened, as we go from fluorine to iodine, atomic size definitely increases. Bond length of CX bond also will increases, and CF to C iodine bond length is increasing. When bond length increases, what happen? CF to Ci bond strength will what happen? Decreases here. So what I'm writing here, bond strength decreases, okay, bond length increases. From where? Fluorine to fluorine actually. Very simple concept it is. Next, bond strength directly proportional to bond polarity. If you want more polarity, bonds, for example, I'm writing here CF, okay, and I'm writing here Ci. Now, where we get more polarity, CF or Ci? Where we get more polarity? CF, because it is having
CF.
more bond strength. It is having what? More bond energy or bond strength. Therefore, you are getting more polar. What is the meaning of more polarity? Means what happens? See, this is actually more electronegative, right? Fluorine is what? More electronegative. When it is more electronegative, we get more negative character. Now, if it is more electronegative, definitely it will be more electropositive. Now, it will get more positive character. So, developing of more positive character, developing of more negative character because of what actually? This bond polarity, isn't it? So, what I mean to say is that very simple. Here, bond strength is less. So, we are going to get here less electronegative and less electropositive character, isn't it? Next. Nature of CX bond. Let me see now further of nature CX bond. A bond polarity is directly proportional to electronegativity difference between what actually is carbon atom and halogen atom. Just now we seen this one. You observe here what happened? This just now we seen. Now which is more electronegative? Fluorine, right? So fluorine is what? More electronegative. Therefore, you are getting what? More polarity, more bond polarity you are getting here more actually. Whereas here if you observe what happened? This one is what? Less electronegative. Less electronegative. You are getting what here? Very less bond polarity. The bond polarity is very less. So why? Because if it is less, what happens? The difference also, the difference between the electronegativity of carbon and iodine also will be less here. If it is more, what happens? The electronegativity difference also will be more actually. So that is the reason what they are saying actually here. Bond polarity is directly proportional to electronegativity difference between the carbon atom and X atom, isn't it? So electronegativity difference, if you observe what happened, as we go from fluorine to iodine, electronegativity values of halogen definitely will be decreases. That means what happened? CF2, isn't it? C chlorine, C bromine, and C iodine, where we are going to get more electronegativity difference here. Here it will get more electronegativity difference. Okay. Here we get less electronegativity difference. That is the reason it is less polar. This one is more polar. All these informations are very, very important for dipole moment. So to explain the dipole moment, I am explaining these things actually. So remember, bond polarity, bond length is very, very important for you. That to get the dipole moment, that is very important for examination point. Okay, so hence bond polarity and bond strength of the CX bond decreases from CF to CL. So this is the point also you need to remember. Okay, bond polarity and bond strength of CX bond decreases from fluorine to iodine of carbon. Because of this, what happened? The order of reactivity, if you observe what happened, the order of reactivity, which is having more reactivity, just now told you this one, where we can easily break bond, Ri or RCl bond, we can easily break.
Ri.
Ri bond readily we can cleave because bond strength is what? Very weak. So this bond can be easily cleaved here. So because of this, what happened? Which will participate readily in chemical reaction? Definitely Ri. For example, if I write like CH3 chlorine, CH3 Br, and CH3 iodide. Now, which will participate readily in chemical reaction? Tell me. Methyl iodide.
CHI.
Methyl bromide. Yes.
Methyl iodide.
Methyl iodide or iodomethane, both are what? Iodomethane is IUPAC nomenclature. Methyl iodide is common name. So definitely this will undergo readily chemical reaction. Next. Some comparisons of bond length, bond enthalpies, dipole moment. We're going to discuss now. Now, first of all, we see. Let me see. We are saying what happened. Bond length is increasing. Bond energy is what happened decreasing. And how it is decreasing, you see. I have taken here fluorine, chlorine, bromine, and iodine. See, bond length, what happened here? 113 to 178, 178 to 193 to 214. What happened? Increased here. Increased. Next, bond enthalpy will definitely decrease. Yes, it is decreased. 315 to 234, it is decreased here. Now, dipole moment, if you observe what happened, so it is decreasing. No doubt it is decreasing, right? 1.86, 1.83, 1.63. Now, what about here? What about here? It is not, it is what actually increased here. That means here what happened? Increased. Now, in examination, they are asking this question. In examination, what happened? Nobody asked values. Write the values of bond length 139, 178, 193, 214. Don't remember that. Leave it that. Nobody asked in examination what is the bond length of CH3I. Okay. So that is meaningless. So what they ask actually? Order. Increasing or decreasing. Only that they will ask actually. But here, what is the thing we are getting here? From CH3 F2 CH3, this thing you need to observe here. What is happening here? Increasing. Increasing. From CH3 to Cl and CH3 to Br and CH3 to iodine. Now what happened here? Bond, the dipole moment is what happened? Decreasing here. What is the reason? This they are asking in examination here. Why? Otherwise what happened? Give the correct order of dipole moment. They will ask in examination, give the correct order of dipole moment, isn't it? So in that case, what we have to give? CH3Cl, CCl, then what happened? CF, then what happened? C, Br, then Ci. This is the order of what? Dipole moment. So in examination, you may get this type of questions. Which of the following is the correct option? Dipole moment. CCl is having more dipole moment than CF and CBr like this, like follows. So let me discuss now the reason behind this one. So this is very important. Remember the order. Don't remember the values. Order you need to remember. I am repeatedly saying why, because if you listen carefully what happened, no need to practice more number of times. If you practice 1 or 2 times what happened, you can remember for up to exam time. So listen carefully. The dipole moment, isn't it? Order. Then we'll see the reason here. What is the reason also? Let me see. It will come after that. Let me see that just now. I'll take a white paper and on that I will discuss it. Here I will discuss. What is the reason also? Let me see. So what happens in this case actually, when you compare actually dipole moment definition, anybody? Dipole moment. Anybody? Definition, it will directly proportional to what? Charge. Okay. And it also directly proportional to what? Distance also, length also.
Distance.
Directly proportional to charge, directly proportional to, isn't it? Bond length. Now tell me bond length order. What will be the bond length order? CF is what happened? Lesser than C chlorine. And this is actually what? Bond length order I am writing. CBr and C iodine. This is the order of what? Bond length. BL. The charge means nothing but polarity. Nothing but polarity. Polarity. Now polarity will be definitely CF is greater than CCl, CBr and Cl. This already we discussed. Order of bond length, order of polarity. Okay. Now what you are observing here, this CF is having, in this case, less value. In this case, CF is having more value. More value actually. Now dipole moment should depend upon charge or bond length. For example, listen here, if dipole moment depends upon charge. Now which will have more dipole moment, tell me? If dipole moment depends upon polarity or charge, which will have more dipole moment, tell me? CF or CCl or CB or anything? My question understood here. If dipole moment is depending on charge, polarity, isn't it? Which will have more dipole moment? Are you listening?
Yes, sir.
CI.
My question understood here. Whichever is having, I'm giving answer now. Okay, whichever is having more polarity, that will have more charge, that will have more dipole moment. Correct? Now tell me, according to the charge, according to the polarity, which will have more dipole moment?
CI.
C.
CI.
Which is having more charge? Tell me better.
CF.
CF, sir. CF.
CF is having
CF.
more charge or more polarity, right? It is having what? More polarity. Okay, don't get confused here. It is having what? More polarity we get when you have more electronegativity. Which is having more electronegativity? Fluorine. Therefore, it will get more polarity, right? Now, the question is that when you have more polarity, definitely mu also will be more because both are directly proportional. Charge or polarity CF, definitely CF has more dipole moment. It is having more mu. Okay, but if you observe this one, second thing, more bond length, isn't it? More dipole moment, isn't it? If you have more bond length, more dipole. If you, according to the bond length concept, which is having more dipole moment according to bond length concept?
CI.
CI. But what happens here? In the case of CI, of course, you are having more bond length. Okay, definitely you should have what? More dipole moment. Mu means what here? Dipole moment. But what happened here? In the case of what? CI, which factor is dominating here? Charge is dominating. The dominating factor is what? Charge. So when charge is dominating towards dipole moment, so charge means what happened? Polarity is dominating. So when polarity is dominating, what happened? The Ci polarity is very less. Okay, when polarity is dominating, Ci is having what? Less polarity. Therefore, it is having what? Isn't it? This is charge is dominating. This one is dominates. Because of this, what happened? Dominates here. It is having less dipole moment. Okay, it is having less dipole moment. According to the concept, you are getting that. Now, what about between CF and chlorine? Now here, it is having more bond length, right? It is having more bond length and is having less polarity or charge. Now here it is having less bond length, It is having what? More polarity. Understood all of you? Now in the case of this, what is happening in the case of CF, isn't it? Bond length is dominating. This bond length character is what happened? Dominating. This is dominates. So cumulatively, if you observe what happened, charge and bond length, if you cumulatively observe what happened, dominated by whom? Bond length. Now, which is having more bond length, CF or CCl? CF is
CCl.
having more bond length.
CF.
Which is having more bond length, CF or CCl?
CCl.
CCl.
CCl. Why you are getting confused? Everything I have written, you are saying what? Is it visible for you? What I am writing is visible for you? कुछ तो बोलो बेटा.
Yes, sir.
Shall I write big letters? You watch in full video, full screen you have to watch. Then it will be easy for you. Right, leave it this one. Now let me see now again, continue this one. Now which is dominating here? Bond length is dominating. When bond length dominates, what happened? Definitely what happened? CCl is what? Having more dipole. In order to avoid the confusion, simple thing I will say. Simple, with only two statements I will say. First statement. So CCl is having more dipole moment when you compare with, this is the dipole U order. U means what here? Dipole moment order. Okay, dipole moment order. So dipole, if you observe what happens, CCl is having more than CF. What is the reason here? Dominating factor by the bond length. So bond length is dominating. Bond length dominates. After this, what happened? CBr, then actually what happened? Cl. Now in this case, what happened? Dominating by charge. Charge is nothing but polarity. Polarity dominates. Polarity dominates. Because of polarity dominating, what happened? Less polarity, therefore less dipole moment here. In this way, we can easily. One is called with respect to bond length, other is with respect to bond polarity. So why CCl is having more dipole moment? Because CCl is having more bond length than CF only. Among these two, what happened? You have to compare. Then CF, and that is the reason is having more dipole moment here. Okay, this is about the, isn't it, dipole moment actually. Let me see now MCQs actually. Now the nature of RX bond in alkyl halide is non-polar, polar, or both A and B, or what? None of the above. Tell me the answer. The nature of RX.
Non-polar.
Which type of nature is having?
Polar.
Polar nature.
Polar.
Giving, I think. Remaining they are sleeping. As we go from fluorine to iodine, electronegativity value of halogen
Decreases.
decreases. Very good. Very good. Next. As we go from fluorine to iodine, atomic size
Increases.
Increases.
If you remember this one, you will definitely remember bond length and everything you can remember easily. Reactivity order from primary alkyl halide, which is the highest correct one. Order of reactivity. Which order is correct? Which option is correct? Order of reactivity.
D.
D.
B.
B or D? Bombay or Delhi?
Delhi.
Donkey,
Delhi.
sir. Donkey.
Bombay.
Delhi.
Okay.
Dubai.
You is saying Dubai. इधर से दुबई जाते डायरेक्ट. Methods of preparation. Next topic is important topic is preparation methods. Now we'll move to now preparation method. How to prepare halo. So I will take in this one two parts. One part is for preparation of haloalkanes. Second part is preparation of haloarenes. Yesterday we discussed what is the difference between haloalkane and haloarene. Okay. Now yesterday I have sent that WhatsApp also, that copy what we discussed, everything I send that one. You have to watch that one. Okay. Don't sit in the class without seeing that PDF, isn't it? You have to watch everything so that what happen easy for you. Haloalkane means what happened? sp3 carbons will be there. Haloarenes will be having sp2 carbons, okay, directly linking with what? Halogen carbon. Now first of all we'll do from alcohols. First preparation is what? From alcohols. Okay, have you written in your notebook all the bond length order, bond strength order, and polarity order, and as well as dipole moment order? So write down in the notebook these 4 orders. Remaining no need. Simply write down dipole moment order, bond polarity order. Take notes from alcohols, preparations of halo alkanes by using the alcohols. So the reactant is here alcohol. Okay, the reactant is what here? Alcohol, isn't it? The reactant is alcohol, isn't it? So what is the reagent we are using here? HX, isn't it? The reagent you are using is HX. X means already you know, chlorine, bromine, iodine, isn't it? In the case of this one, X is equal to what here? Chlorine, bromine, and iodine. But we can't take fluorine. I will explain that one in the next slides. It will get actually. Okay. Now, what is the X here? Chlorine, bromine, and iodine. Don't take fluorine because of high reactivity. That is different. Okay. Leave it that. Now, alcohols. This is a statement we are writing. Alcohols react with HX in presence of anhydrous zinc chloride to give alkyl halide by dehydration reaction. So this is alcohol. You see, this is the alcohol. Alcohol, isn't it? This one is what? HX. HX means hydrogen halide. This is what? Hydrogen halide. Hydrogen halide. Okay. Now you see reaction taking place like this. ROH reacting with HX. Now water is removed here. H from halogen, hydrogen halide, OH from the alcohol. They are removed here. Okay. In presence of reagent is called anhydrous zinc chloride to give your RX plus water. You see this water, you see H plus and OH minus removed. R and X both are joined here. These two are joined. Now what we got the product here? Halogen, halo alkane I got. This is called halo alkane, isn't it? This is called what? Halo alkane. All of you make in notebook like this. Alcohol, hydrogen halide reacting in presence of anhydrous zinc chloride to give halo alkane plus water. Water is not at all byproduct. Leave it that one. So very simple reaction. Now important thing is that anhydrous zinc chloride, this anhydrous zinc chloride in presence of HX, isn't it, is called Lucas reagent, isn't it? The name of the reagent is called what? Lucas reagent. You may get some questions in a multiple choice. Among these, which is the Lucas reagent? Concentrated, generally HCl, in presence of anhydrous zinc chloride. Concentrated HCl, isn't it? In presence of zinc chloride, anhydrous, without any water in the crystal structure. Okay, that is called what? Lucas reagent. So what is the Lucas reagent? Concentrated HCl, isn't it? In presence of anhydrous zinc chloride is called Lucas reagent, isn't it? This one. Okay, this one. Concentrated HCl, anhydrous zinc chloride, isn't it? Now the process is called what? Gruce process. This reaction is called as Gruce process. This is called Gruce process. If you prepare alkyl chloride. So we'll take an example here. How to write this one? We'll take one example here. We'll take some examples. Okay, I will write one example. Now I will take here what? In the place of R, I will take CS3, CH. Is it visible for you what I am writing?
Yes,
What I am writing?
Yes, sir.
Now I am taking in the place of X, I am taking HCl, right? In presence of what actually? Anhydrous, isn't it? Zinc chloride. What is happening? Water is removed. Now what you are going to get? CH3, CH2, Cl. Ethyl chloride you are getting. The name of this one is called ethyl chloride. Anybody? What is the IUPAC name of this one?
Chloroethane.
Chloroethane. Very good. This is called what? Ethyl alcohol. Ethyl alcohol. Ethyl alcohol. IUPAC name is called ethanol. Okay, IUPAC name is called what? Ethanol. So ethanol is giving ethyl chloride. Very simple to write the chemical reaction. In the place of R, you can put anything. You put what? CS3 and write down the reaction practice. This one put CS3OH. Okay, reacting with what happened? HCl. In presence of anhydrous zinc chloride. Now write down the product. In this way, you need to practice. Put sometime R equal to CS3, equal to CS3, CH2, CH2. Like that, you can put here. And you can practice that. Take different R groups, ethyl group, methyl group, propyl group, butyl group. Like that, you can isopropyl group, tertiary butyl group. You can take anything actually, which is an alkyl group actually. Okay. So these are the actually preparation. Now we will see some important points. Reactivity of hydrohalic acid. Let me see which is more reactive. Already you know this one. Okay. HI is what? More reactive. Because of what? Bond strength is what? Very less. This is what? More reactivity if you observe. Which is having high reactivity? HI is more reactive when you compare with HBr. Because of what happened? Bond length is more. Therefore, bond strength will be less here. So order of reactivity, HI is what? More reactivity. Now order of alcohols if you observe. So already yesterday I told you which is tertiary, which is secondary, which is primary. I already told you what is tertiary, what is secondary, what is primary. So I'm writing here what happened like this. Writing here like this. If I write like this, I'm writing an order. You also copy this one. If you don't have enough time, when I send the PDF, no, you download that PDF and write down in the notebook. No problem. This is because whatever I'm writing, no, that will not display on the PDF because this I'm erasing this one. So that is the reason. What I'm writing, you can write that. Whatever is displaying on the PDF, no, here PPT, that will be you will get from the PDF, no problem. But what I'm writing here, that you don't get on the PDF. If you want that one, I will make that one, no problem. This one also I will save. But you will lose these things actually. It will disturb these points actually. If I write something here, what happened? You can't visible that one. That is the reason I'm deleting these things actually. Now CS3, CH3, OH. Next CS3, CH2, OH. And finally CS3, OH. Now tell me this one, which type of alcohol it is? Primary, secondary, tertiary? The first one, this one.
Tertiary.
It is a tertiary. How tertiary? See,
Tertiary.
very simple, you see. Alcohol, OH, in previous case we have taken halogen, now I will take alcohol. Now OH bonded carbon, bonded to 3 carbons. You observe here, OH bonded carbon, bonded to how many carbons here? 3 carbon. This one I am selecting, this one I am selecting, okay? OH bonded carbon, bonded to 3 carbons. It is called what? Tertiary alcohol. Isn't it? Okay, next. OH bonded carbon, bonded to how many carbons here? 2 carbons. So this one is called what? Secondary. Now OH bonded carbon, bonded to 1 carbon, bonded to 1 carbon. This is called primary. OH bonded carbon, not
Primary.
called primary. So order of reactivity is what? Always tertiary alcohols are more reactive, isn't it? This order of reactivity, which is more reactive here? This one is the more reactive, isn't it? This one is less reactive. Reason behind this one very simple. I will explain here. After removing the OH, what we get here? CS3, CH3, and here also what? CS3. After removing the OH bond, see between carbon and oxygen, which is more electronegative? Between carbon and oxygen here in this case, which is more electronegative?
Oxygen.
Which will get negative?
Oxygen.
Oxygen will get negative, carbon will get, whichever is having more group number, highest group number will have highest negative character. So oxygen is being 16th group, this is being 14th group, definitely it will have. Now if this bond is broken, what happened? Carbon will get a positive character, right? I'm writing a positive character here like this, a positive character here. Now this positive character you have studied in the 11th class, inductive effect you have studied. Now this is a plus I group, this one is a plus I group, and this one also plus side group. These plus side groups increases the stability of the carbocation. Plus side groups increases the stability of carbocation. Therefore, it is more stable, easily participate in the chemical reaction. In the case of this one, how many plus side groups we get here? In the case of this one, how many plus side groups we get here? Only 2 plus side groups. Only 2 plus side groups here. Plus side, plus side. In the case of this one, CS3, CH2 plus
1.
plus side groups are getting only 1 plus side group. Here no plus side group. In CS3OH, you are not getting any plus side groups here. In this case, methyl alcohol, you are not getting 0 plus side groups here. 0 plus side. Here 1 plus side group. Here 2 plus side groups here. Here 3 plus side groups. As number of plus side groups are increasing, isn't it? It's the reactivity also increases, isn't it? In examination, nobody asks you what is the reason, but simply they will ask order of reactivity. You have to see which is having tertiary, which is having secondary, which is having primary. You will get the answer. Okay, this is about the reactivity order. So in this slide, what you are learned here, order of reactivity of hydrochloric acid and order of reactivity of alcohols, isn't it? Okay, and their order, right? Next slide, if you. Now, method of preparation by using the SOCl2 as a isn't reagent. I'm changing only reagent here. In the previous case, the reagent is HX. Reactant is alcohols only. The reagent is HX. Now, what I'm using, the reagent I'm changing, that is called what? Sulfonyl chloride. The reagent I'm changing here, what? Sulfonyl chloride, SOCl2. So, when you use SOCl2, what happens? Now, alcohol is same. Alcohol is what? Same only. This is alcohol. Reactant is same. But I have taken here sulfonyl. The name of this one is called sulfonyl chloride. Sulfonyl chloride it is. Okay. In presence of what? Pyridine. This is the solvent generally we'll take here. This is a solvent you can take. Now, it never participates in the reaction. It is just provide the surface for that solvent. It is no. Now we are going to get the product here. How to get the product here? One is RCl, other is what? SO2 and SCl. Now, in this, what happens here? This oxygen will move to here. So we are getting sulfur dioxide. When one chlorine will move to where here? You are going to get here HCl. And another second chlorine, no, the second chlorine will move, and you are breaking this bond completely. So you are going to get RCl, SCl, CH4. Now you practice this chemical reaction 2 or 3 times by placing R equal to, okay, place R equal to CH3, R equal to CH3, CH2, R equal to something CH3, CH3 like this. In this way, you can practice this chemical reaction. In the place of R, put CH3, put something what CH3, CH. I will write one thing here, CH3. Okay, just a minute. CH3, CH2, OH plus SOCl2 in presence of pyridine, isn't it? What we are going to get? CH3, CH2. In the pot you are going to observe here, you see, in the place of OH, you are going to get Cl. Okay, this is happening. Now extra you are going to get byproducts are SO2 plus HC. SO2 plus SC. So very easy to write. In the place of OH, what we are getting here? Cl we are going to get. This is common for anything. So in this way, we need to practice. Now this reaction name is given, that is called what? Darjan method. The reaction name is called what here? Darjan's method. Okay, the name of this reaction is called Darjan's method actually, isn't it? Now let me see here. You have seen what some reactions here. Okay, just now we have seen some reactions. You see, you have seen some reaction previous case with HX, Lucas reagent, something we have taken HX here. Okay, but if you observe what happened, which method is very good method to get the chloroalkanes here. So in that case, what happened? Darjan method is very, very good method, better one to get the chloroalkanes here. Why that is? Okay, in examination, you will get this type of questions actually. Okay, following which method is the best method for the preparation of chloroalkanes? In that case, you can take Darjan method. What is the reason behind this one? If you observe what happened in the last case, you got some, you are getting some byproducts, but here sulfur dioxide and HCl both are gas molecules, isn't it? They will actually evaporate from the reaction mixture. So you are losing that one in the reaction mixture because these are the gaseous molecule. They can escape from the reaction mixture. The remaining one will be alkyl chloride. The remaining one will be alkyl. This is the reason. Darjan's method is best method. It's the best method, isn't it? To prepare chloroalkanes, isn't it? To prepare chloroalkanes, the byproducts are removed in vapor state. In the vapor state, what happened? They can be easily removed here, isn't it? So this you need to remember. So Darjan's method is best for preparation of chloroalkanes. This point is very important for you. This you may get in multiple choice type of questions like, isn't it? Darjan's method is best method to prepare chloroalkane. What is the reason? So whatever the byproducts called HCl, sulfur dioxide, they can be removed as what? Vapor state. This is the point you need to remember. You have to note this point in notebook. Okay, note this reaction, and this point is very, very important. Next, how to prepare the, we are seeing what happened, chlorine, chlorine, chlorine. How to prepare bromines here? Okay, how to prepare the bromides, alkyl bromides. In that case, we'll take sodium bromide and H2SO4. What we are taking to prepare RBr, what we are taking sodium bromide and H2SO4. Okay, now we are going to get here RBr and NaHSP. Very simple to remember here. How to remember this one? Very simple here. Let me see. You observe here what happened. Remove this OH. From this, remove the hydrogen. Okay. Now send this Br here. And send this sodium here. You will get the products. Okay. Very simple. Otherwise, remove this OH. Remove this OH. Put here bromine. You got the main product. And remaining is what? Byproducts. Very simple to remember here. Remove the OH, right? And place what happened? Bromine from where? Sodium bromide here. You are going to get alkyl bromides. So this is the best method for the preparation of what? Alkyl bromides. Next we'll see the iodides also will be there, but we'll see that one. Okay. Right. Which of the following is the reagent used in the Groves process? Which reagent you are using? Anybody?
Option B.
B.
Concentrated HCl plus anhydrous ZnCl.
Anhydrous zinc chloride. Right. Now tell me the answer for this one. Which are
C.
A.
A and C.
A and C.
And
A
C.
and C. D. A and D. Both are removed. Right. I will take some more preparation methods. Okay. With PCl3, PCl5, SOCl2 already completed this one. Okay. Now we'll see the PCl3 and PCl5 also are important. PCl3 and PCl5 are also what? Important. Now again alcohols only. Right from what we are starting here, we are preparing from alcohol. By using what actually HX, by using SOCl2 we completed. Now we are using what reagent is called PCl3 now. Okay, let me see PCl3 now. PCl3 I have taken. Now when you take PCl3, take 3 moles of alcohol. Okay, 3 moles of alcohol react with what? 3 moles of alcohol reacts with what? Just a minute. Moles of alcohol reacts with what? 1 mole of PCl3 to give what here? 3 moles of. That means what is happening? 3 chlorines, isn't it? Are moving towards you. And you are going to get here H3PO3, isn't it? Phosphorus acid. You are going to get H3PO3, phosphorus acid. It is called phosphorus acid. Now, very simple. Alcohols, when they react with first trichloride PCl3 on heating, it will produce 3 moles of alkyl chlorides, isn't it? And byproduct is phosphorus acid. Okay. Now if I take what PCl, already they did, no problem. If I take what PCl5, you take one example here, CS3CH2OH. Okay, this is called ethanol. Already we discussed this one. PCl3 heating, we get 3 moles of CH3, CH2, Cl, isn't it? So this is we get 3 moles. Here also we get. Okay. So from alcohols with reagents such as PCl3, PCl5, and suppose we'll see PCl5 also. PCl5 also, let me see. Again on heating. So here we get only 1 mole of alkyl chloride. Only 1 mole only we get. Remaining we get here POCl3 and HCl. Okay, POCl3 and HCl. These are the byproducts, and this is the main product for us. And these two are the byproducts. Okay, ROH on reacting with PCl5, 1 mole of the that means with PCl3 we take 3 moles of alcohol and we get 3 moles of alkyl chloride. With PCl5 we'll take 1 mole of alcohol, we get 1 mole of alkyl chloride, isn't it? And for example, in examination, what happened? They may ask like this also. Okay, by in examination they may ask like ROH reacting with what? X to give RCl plus H3PO3. Now what is X? They will ask. Tell me what is X here? Is it possible?
PCl3.
Yeah, like that also you may get questions here. Okay, they may what is X here? So simply X is nothing but for example, in place of this one, if you have like if they given like this HCl, okay, POCl3. Now definitely X will be what actually?
Chlorine.
PCl5.
Okay,
PCl5.
So you have to practice this one. Remember one thing: organic chemistry is very simple to understand, but very difficult to remember. It is very, very difficult to remember. Very simple to understand it is. So when you're going to remember here, if you practice more number of times, instead of writing 5 to 10 times, you make like this. Where the changes are occurring. If you practice in that way, you're going to remember that. Otherwise, writing the same reaction 50, 100 times or 1000 times, what happened? You don't have any use for that. How you have to write where the change is occurring? You have to practice like this. Okay. Now what is happening here? In place of OH, I am getting here chlorine. Okay. Now PCl5 is converting into POCl3, isn't it? And one more chlorine react with what happened? Hydrogen. You are going to get HCl. So main thing is that this product. This is a product. If you practice like that, what happened? It is easy for you. Otherwise, you write in sentence. When alcohol reacting with phosphorus pentachloride on heating is producing alkyl chloride plus HCl and POCl3. Practice in such way, what happened? It is easily removed. The name of this one is called what? Phosphoryl chloride. This is called sulfonyl chloride. This one is called phosphoryl chloride. Now take an example here with alcohol. This is the example I have taken with alcohol. So you can take any example. You can take CS3, CH2, CHOH, or you take CS3, CH2OH. You can take CS3OH also. That is your wish. You can take primary, secondary, tertiary alkyl. Alcohols you can take. Okay. Any primary, secondary, tertiary alcohol you can take to get the products. Okay. This is the product. POCl3. Right. Now, which is the best method? Using PCl3 or PCl5 or SOCl2? Which is the best method? Tell me. To get the alkyl halide, using the PCl3 or using the PCl5 or using the SOCl2, which is the best method for preparation of alkyl halide?
SOCl2.
SOCl2. Whatever the byproducts, they are getting exhausted. They are getting evaporated from the reaction mixture. But here, these cannot be evaporated. These still remain in the reaction mixture. You have to separate these. You have to separate these things actually. Separation, it needs some operations. Distillation method, simple distillation, fractional distillation. It requires. It is very difficult. Here also, what happened? Removing this POCl3 is what very difficult for us. In the previous case also, removing that one, that S4, the H3PO3. In the previous case with PCl3, the byproduct is what actually? H3PO3, orthophosphorus acid, phosphorus acid. That is also very difficult to remove actually. So this is a thing actually. You need to remember. Okay, among these three, best method is what? SOCl. It's already we discussed. Here, the reactivity order with PCl3 or PCl5, anything. What will be the reactivity order? Same reactivity order. Already we discussed this one. Tertiary, always more reactive than the secondary. Secondary is more reactive than the primary. Right? What will be the answer here?
SOCl2C.
SOCl2.
C is the option. It's a very important question it is. Very important question it is. Which one is order correct? Order of reactivity. Order of
A.
very good.
A.
Phosphorus triiodide. Possible for you? What is the product when alcohol is treated with phosphorus triiodide? Pi3.
C.
Alkyl iodide.
So actually, I have taken PCl3, I have taken PCl5. Now you can take in place of Cl3, you can take PBr3 or you can take PBr5. You can take even Pi3 or you can take Pi5. Same reaction in the place of chlorine, you may take bromine or you may take even iodine. The reaction process is what same, but the difference is what in place of chlorine, you can place bromine, you can place iodine. Now tell me what is the answer now?
C.
Alkyl.
Alkyl iodide.
Alkyl iodide. You will get this one or PCl5 or SOCl2. You will get this one with what? PCl3 or PCl5. Now, important thing, one more important thing is that sometimes they don't give PCl5. Directly, they don't give PCl5. They will give directly, they will give this one, phosphorus plus chlorine. Phosphorus plus chlorine, isn't it? This is the red phosphorus. Okay. Now, in this all, when phosphorus chlorine they react, what happens? They will give PCl5 or PCl3 only. They will give no. So sometimes in the place of PCl5, they may give phosphorus plus chlorine also. So don't get confused in that case. Now tell me the answer for this one. Tertiary butyl alcohol when treated with concentrated HCl gives what is the product? First of all, you write the reaction, all of you. Tertiary butyl alcohol. Yesterday only I told you. Compulsory, you have to remember this tertiary, secondary because you have to make the structure. Tertiary butyl alcohol. How to make tertiary butyl alcohol? I am writing here. Carbon bonded with OH. If you don't remember that one, observe here. How to make tertiary? OH bonded carbon bonded to 3 carbons. Correct or not? Tertiary alcohol means what? OH bonded carbon bonded to how many carbons? 3 carbons. Now put here 3 hydrogens here because only one bond is there. Put 3 hydrogens. Here also put 3 hydrogens. Here also put 3 hydrogens. Now this is called tertiary butyl. How easy you see? How simple it is to write the alcohol, tertiary butyl alcohol. Now number of carbons you see? 4. Butyl means how many carbons I have kept here? 4 carbons. You see? 1, 2, 3, 4 carbons. Very simple to write. Now when this reacting with what happened? HCl. Lucas reagent in presence of anhydrous zinc chloride. Now what happens here? OH will be removed. Okay. Now we are going to get this is the answer. But you have to make IUPAC nomenclature.
Both A and C.
Now tell me answer.
D. Both A or C.
Both A and C. A is actually common name. C is actually IUPAC name. Actually. Yesterday only we discussed the IUPAC nomenclature. This IUPAC nomenclature. Yesterday only I told you this one. Yesterday only I give numbering from where? Anywhere. 1, 2, 3. You will get the answer. 2-chloro, 2-methyl, propane. So answer will be what? Both A and C. So in examination, what happened? They will give in this way. So you have to make in terms of structures here. By seeing then the tertiary butyl alcohol, you can't make the answer. You have to convert the tertiary butyl alcohol into structure like this. Into this structure like this. Then only what happens, you will get the answer. Otherwise, what happens is very difficult. So what I'm saying here, you have to practice yesterday nomenclatures, yesterday common names, yesterday IUPAC nomenclatures. Practice 2 or more times you practice what happened, it will be easy for you. We'll take some more parts here with the next by using another things, hydrocarbons. Until now, what we discussed here by using alcohols. By using alcohols, again I'm revising this one, what we discussed here. Are you having class now? Are you having class now?
Yes,
Yes,
sir.
sir. Maths class.
When
Maths.
you're having at 11?
Yes, sir.
I will do. I will just a minute. I will, if possible, I will complete. Okay, I will complete tomorrow. I will take. No, it is difficult. It takes something 15 to 20. Shall I continue? Otherwise, 5 minutes. Okay, no problem. I will take next class. This topic I will take next 20 minutes. So tomorrow at what time you are having class? Tomorrow what class you are having? Thursday?
Biology.
What time you
Biology.
are having?
Bio.
At what time you are having class? At 11 o'clock. So what time is for you is better timings? If I take class 1 hour, which is better? Which timing is better for you?
Evening.
Evening at what time?
Sir, 9:30.
Evening 9:30. Morning 9.
No,
No,
sir,
sir.
morning.
7 to 8 ना तो 8 to 9
Morning maths class है.
Yes.
at night.
Math class is in
8 to
evening,
9.
8:30 to
Sir, from
9:30.
9:30 to 10:30.
Tomorrow 9:30 to 10.